Alright, okay, 7:03, so I'll just get started. So, welcome to week 2, data manipulation. Yeah, so it's the first Jupyter workshop. If you guys didn't have an opportunity to go through the workshop yourself, I'm going to be essentially going through the solutions on it, over it, but I encourage everyone to type in or to program in some of the fill-ins yourself afterwards to get you familiar with the way we're doing things. So right now I'm just going to open up Jupyter. So here's my terminal. You can open up Jupyter something like this, and then once it starts, it's going to open a new tab in Chrome, and here you can see everything. For those who are switching to like R and Python, if you want to choose a specific language, you can basically create different types of notebooks and change your kernel. I'm just going to go over to Python one because it's Python, but right. Matplotlib. Actually, wait. I'm going to clone this one. If I can clone. I'm not sure if I can clone. Edit, file, make a copy, yeah. Alright, so yeah, I'll just call this work week 2 answers. Alright, workshop 2 answers. So, first thing you'll see is, wait, this is not the right notebook. This is workshop 2. Oh wait, I think I messed up. Okay, no, it's workshop 1. I'm bad. Sorry. Workshop 1. But yeah, I wanted to show you guys how to open up Jupyter. That's why I didn't open up beforehand. But okay, workshop 1, simple data transformation. I don't know what the comments, so it's not. Yeah, so here's the workshop. If you guys read over it, you'll know that it's sort of like an assert-based workshop. So you'll have to basically type in your code, and if you get the answer right, you're going to fulfill assert statements, and that's basically to ensure that you have completed it in the right way. So, okay, yeah, so let's first off run every cell. I assume you've read the first part of it. So here we're just importing some of the libraries that we're going to need throughout the workshop. And so yeah, it's pretty simple request. I don't think I make use of requests actually. I should probably remove that. But yeah, to introduce you guys to the format, first thing you'll notice is Numpy, which is linear algebra. It's pretty useful if you're getting into more advanced data analytics when you're trying to maybe create, I don't know, or work with libraries that require it. You might have to store data types using NumPy objects. Pandas is the primary library that we're going to be using. It stores a lot of data, and I'll explain as we go further down through the workshop. But yeah, there's no fluff. Okay, so that's the beginning. So I jump right in and explain how when we're trying to store data, like if you're familiar with computer science, you may know some data structures, right? Like arrays or stacks, queues, or even more complex, such as like trees or yeah, trees, or I don't know, prefix sum arrays or something like that, right? Well, for data analytics, we just have to store data into workable sections that we can manipulate, and because most of the time when we're gathering raw data from the wild, it comes into a format that's really odd, and the data is not really cleaned and everything, and it's really important when you're working with data to make sure that everything's consistent, and you want to keep things organized, right? And so the very early computer scientists wanted to create a lot of data structures, and data scientists actually created a data structure called the data frame, and they took inspiration from Excel spreadsheets, for example, right, or tables like T-charts or anything, right? So if you look at an Excel spreadsheet, you're gonna have like a header, all the attributes on top, and then every single row is like a data point, right? So all this is usually coming in as a CSV file. So if you look and read the cell, we have a 2D array. It's called, we have an apple, potato, banana, and onion, right? So I'll just explain as we go on. But so this cell basically creates a data frame, and it stores the apple, banana, potato, and onion into like a 2x2 matrix or something. And so here we're basically creating columns that will describe fruits, and this is actually a poor example. I should have thought of it, but the point is to show that you can categorize like this column in a data frame, and every single instance is like an instance of data. So let's say we have let's say every single row represents like a basket of food objects, right? Inside each basket, you can have one fruit and one vegetable, and this will basically describe which fruit and which vegetables in that basket. And so, if you are able to categorize data like this, it makes it really simple, or it makes your data really organized. And so that's why we use data frames. And so just think of them as tables. But as we go on, I explain how CSV files are usually the main way for people to actually store data, right? And because everything's written in an Excel spreadsheet, and so because CSV is really a really common format, Python has this implementation to basically read CSV files and store them into data frames, and there's a built-in function for that, which is right here. And so, yeah. So before I move on, do you guys have any questions on how data frame works, or do you have any misconceptions? I know I sort of ran through this first example, but yeah. If I'm not going to get any comments, I'm going to assume no. But yeah. All right. Yeah, it's pretty straightforward. Think of it as a table. I'll close this tab. But all right. So yeah, so that's the first data frame that we encounter. So right now, throughout the workshop, so we're going to be following through a data set from the Toronto municipality. Toronto basically has this data set where they have taken rain readings from all across the city, and they're called rain gauge readings. I think I have a link to the original website right here. But yeah, basically it'll show you how much precipitation has fallen on a particular meter on specific points of the city, and so they archived it into CSV files, right? So right now we're going to be I've downloaded the CSV files. It's inside the GitHub repository, and it's all in here, this folder, Rainfall data. So you guys don't have to download it yourself when you go through the workshop. But basically, when we imported the data for data frame earlier, we're just reading that data into a data frame. And so, so now that we have our data imported into a variable or into a data frame, we're going to go and try to take a look at data, right? Because we want to see how does it look like. And so, right, when we open up the data frame, we can see that inside the CSV file there are these instances or rows. So the ID column is like the ID of I think it's the ID of, that's weird, it has the same ID. I'm not sure, it might be an error on their part. but I know for sure this is the name of the weather station that actually, or the meter, the rain gauge meter that actually measured the precipitation, the date when it was recorded, and the amount of rainfall. So it was probably really sunny on this day. Just to show you guys that this is a data frame, I'm going to run the Python type on this variable, and yeah, you can see that this is a data frame. And so this brings in, oh, now that we know it's the data frame, I should probably explain what this function does. Head. Head is a function that basically shows you the first 5 rows of a data frame, and it's really important because you're going to be using this a lot to basically have a glance at your data. And so yeah, so that's pretty cool. That's what our CSV file looks like. You can also open this up in Excel. For smaller data sets, it works perfectly, but for larger data sets, let's say gigabytes in size, you don't want to open up in Excel because it's going to be really slow. So yeah, you can load it up in a data frame and look at it with the head. Sometimes you want to select a certain row. Oh, right. So you know how we have our data frame, right? Let's try to see. I'm trying to grab the first row of the data frame. So let's say I want to get this row just because I want to take a closer look at it, or to store it into a variable. To get the first row of a data frame, we just use iloc and the index, so that's 0, and we can see rainfall row. Oh shoot, I mistyped this. Rainfall. Oh, right, I messed up. I think I wanted you guys to do this. Right. So yeah, we're storing this, and if we look at it, this is it's a row, and it's a row of the data frame. And if we actually take a look at the type of this, we can see that it is not a normal data frame, but it is a series object. So a series object is basically a row of a data frame. Think of it like that. And so we can see there's an ID, there's a name, and the date corresponds to the date on the first index. So we know that I've grabbed the first row in this data frame. I feel like it's pretty straightforward. Oh, yeah. Alright, yeah, so columns. Now, other than... Yeah, so for columns, sometimes we want to look at an entire column of our data set. So let's try to just copy and paste this code, I guess. But what do I want? Sure, let's do is make a variable hold the dates of our data frame. So I want to select all the objects underneath the date header. And if we check this out, we have all the dates in our data frame. So this corresponds to row number, or index number 0, index 1, index 2, all the way to the end. And you see how it like skips because we have 359,000 rows in this data frame, which is a lot. I'm pretty sure Excel wouldn't load this. It might, but yeah. So yeah, so those are pretty simple features, but now I'm gonna do a bit of explaining on some of the process that we will normally use when we're looking at a data set. This is arguably the most important lesson you can get out of this meeting, so make sure you understand this. But yeah, the data science process. So whenever we're looking at a data set, right, we don't really know what to do once we receive our data. Nobody has a clear picture of what they want to do, or of what they should do. We have questions, we usually have questions we want to ask, and these questions will usually help achieve our goal at the end. So let's say you get a data set that explains poverty rates on South Africa for the past 30 years, and you want to see how the trends are doing right now. Is South Africa still going to be poor within the next 30 years, or will they have go over some kind of economic miracle and become really prosperous, right? And so let's say that's our goal, for example. You really don't know what the data will tell you, because that's the point of data analysis. You're here to find something new, right? So normally, to basically reach our goal, we ask ourselves several questions. But the steps we do before we ask the questions are to first inspect the data. This is when we're basically looking at the data, see what the averages of each column is, see what's the mode, the mode, the median, and maybe see which one's the highest, the max value of this column, the minimum value of this column. That's data inspection. We inspect data because that's when we first receive our data set, and we want to take a look at the data. I want to see what kind of challenges does it offer, right? After the inspection, and the reason why we inspect the data is because we don't know what to do, and we're just trying to get a sense of the scope of the project, right? Normalization and cleaning. Oh wait, quick question. Can you guys read the text on the thing before I continue? Because I know I'm on a larger monitor, but it might be tiny for you guys. Can you guys read it? Oh shit, don't read. You don't catch it, we share. Yes, alright, cool, thanks. Yeah, so, normalization cleaning. So, now that we've looked at our data, we may have some questions, right? Why is this column suddenly so, why do the values from this column appear so high? Let's say if it's like, I don't know, like in our example, the precipitation for this area of Toronto. How come this part of Toronto receives way more precipitation than this other part of Toronto, right? It's an anomaly, and we want to answer anomalies because they usually result into findings, right? So now that we have questions from our inspection, we will normally go into normalizing and cleaning. This is to basically, because to make more sense of our data, if we want to intuitively find out why this section of Toronto has more rain, we have to understand we have to make sure our data is cleaned, and we have to get rid of any outliers or any incorrect data that may have been entered into our data set, because those will skew values, obviously. So we have to normalize and clean our data. Normalization is basically making all the values into kilograms, for example, or to standardize a unit. Standardization. That's normalization. And cleaning the data is removing any useless data or any ends or any strings left in a column that's supposed to contain only integers, right? And so this is pretty important because it'll help make sure our data is consistent. And normalization and cleaning is different for every different type of analysis you're doing. If you're looking at text data, if you're looking at image data, you're going to have a different normalization and cleaning process. And so, yeah, gathering insights. This is the interesting one. Before I go on, I gave you guys some homework to basically understand and learn these words. But data are values that describe something. Information is the insight that you gather from data. It's like something that's useful, where data is not useful, and data is not meaningful, information is, right? And so let's go back. So this is step 3, gathering insights. I have something called feature engineering here, and so the whole point of data analysis is gather insights, answer the questions you've received from data inspection, right? So here in data science, we usually have to get creative and come up with new columns or... Oh wait, sorry, I went about this the wrong way, but normally when you look at a data set, you receive values and, oh yeah, it may make sense, but sometimes you want to know more about the values, right? Let's say you have a list of family of names on the Titanic, for example. I'm taking this off of Kaggle. But yeah, let's say you have a list of names of people that died on the Titanic. You want to see what kind of people were male and female, or what kind of families died by taking their surnames. So when we're trying to gather more insights or information out of data, we usually have to make a new column in our data frame and extract the data and to get more data, or engineer more features out of data, or engineer certain attributes out of data. And so you may ask, what are features? Well, features are attributes that are useful. And Oh, I should probably go over attributes. But if you did the workshop, it should be a bit more clear. But yeah, attributes are variables in a data set. Think of them as the headers for your data set. So name of time of day, date, amount of rainfall, all that stuff. Those are attributes, right? Features are attributes that are useful. So much like information is useful data, features are useful attributes, right? And so this brings us over to the whole feature engineering thing, which is what I described earlier for the Titanic surname, trying to find more data or more information from the data that's given. And we're trying to extract useful information. That is called feature engineering. When you're creating new features or more attributes of your data set, you are effectively understanding more of your data from the columns that you were given with in the first place. And so the example I go over here is determining the day of week given a date, right? Because let's say you get rainfall and you realize, hey, you have a dates column that explains when rain was recorded. Well, let's say you ask yourself a question. Hey, I wonder if Mondays are usually rainier than Tuesdays. So to answer that question, you're gonna have to basically look at every single date, run it through a function, and the function will basically spit out what day of the week it was. So, for example, let's go over here. If it looks at like this date, it's gonna say, oh, it's a Monday. If it looks at, oh, these are all Mondays because they're the same date, right? But basically, you're trying to get more data or information out of the attributes you have originally originated with. And so it's pretty important. Because this is basically what gives us information out of our data set. Instead of working with data, we're now working with information, and information is useful. And that's basically it. So once you have the features, or actually no, before I move on, does anyone have any questions about feature engineering and gathering insights out of our data? I hope I explained it. Now's your chance to ask. I'll stay on the chat for a while. This is a pretty tough topic, so it can get pretty confusing, but I hope I distinguished what the difference between a feature and attribute is of your data set, and the difference between data and information. So if you guys have any issues, please type it in the chat, and if not, I'm going to move on within the next 30 seconds. Okay, I guess no one has any questions, so I'll move on. Yeah, so once we've gathered insights from our data set, we are going to try to, here's the fun part, where we're generating machine learning models or trying to use predictions to basically drive our analysis, right? So here, you guys may have learned about linear regression in biology, or the line of best fit. That's a machine learning model, or it's a model. And so like stuff like that is what we're trying to work our way towards, right? So the reason why we feature engineer is so the models we generate are more accurate, because if the models only worked on top of data, it is not that meaningful, whereas information that we specify ourselves is more meaningful for the algorithms that we're going to be putting our data through. So yeah, generating the models. So yeah, throughout the course of our workshops, we're going to go over two main models. First off is linear regression. It's just a quick refresher, but we're also going to go in depth on how to optimize it. So we're going to have like an error function and optimizing function for your linear regressions, and that's going to basically help out with your outcomes. And we're also going to go over k-means, and that k-means is a clustering algorithm. We're going to get onto it a bit later on in the tutorials, but think of it as trying to group a bunch of people together, or group a bunch of data sets together and try to categorize them. Right? So yeah, so let's going back to our rainfall example. Let's say you want to predict how much rain would fall on Tuesdays. So you would probably have a line of best fit of all the rain variables on Tuesdays or on separate days of the week over time, and so using that you'll generate a model. It's different than finding the average because averages may not be like the most accurate. We're trying to basically the models that we're going to be putting our data through will follow trends, and and these models will answer or will adhere to the trends instead of some formula that we have come up with prior. We'll talk about more about models in our third workshop. So last point is storytelling. The whole purpose of data analytics is to tell a story, right? We want to answer the questions that we've had, and at the end we want to present our findings because by presenting these findings, we'll basically make our work meaningful, right? What's the point of looking at numbers all day and generating features if we're not telling a story, right? And keep in mind, whatever you do must help bring you closer to solving your major questions and to help you tell that story of your data set. You are the storyteller, and that's what makes data analytics is so fun and interesting, because every single data set's different and every single data set has its own story, and it's up to you to basically come up with the story and to answer your question. So let's first start off with inspecting our data for our data set that we've just imported. So the first function I'm going to use is the describe function. It basically gives you some general insights on the data. So yeah, you can see the count of columns, mean, standard deviation, min, all this stuff. Oh, mean. Huh. This is the ID column, which is basically useless. You can ignore that. But rainfall. Yeah, you can see like on average we have 0.12 millimeters of rainfall, and for every single reading. Standard deviations 0.14. You should know that from the stats workshop. The minimum rainfall. This makes sense. On a sunny day, there won't be any rain, so there's no rain. So the rainiest day from our data set incurred 9.14 millimeters of rain. I'm pretty sure it's in rainfall because I did some research on it's in millimeters because I did some research online and said that most rain gauges measure in millimeters. So yeah, that's the describe function gives you some basic info. It's very important because instantly you can see if rainfall, let's say maximum is like 1 billion, right? Like you're like, wait, what? Why is there 1 billion as like the highest precipitation amount? Then you'd probably think to yourself, oh, it might be an outlier or something, right? And so it'll this describe function will basically show you any anomalies right off the bat. Yeah. So moving on. Okay. Yeah. Yeah, I just wanted to make sure no one had any questions. The drop NA function. So let's say you have a data set and then you get like a lot of NANs, which means it's a null value or something. There's no data, right? You want to get rid of stuff like that. So let's run the NAN function. Oh shoot. And this function will basically drop all the NAs from every single row inside your data frame. And now let's rerun the describe to see the data after we have dropped it. As you can see, we had 359,000 rows when we first ran it, and now we have 347,000 rows. So a considerable amount of our data had contained null values, and so this function effectively got rid of them. And if you ran like values like this into like another function further on the line that may have done a linear regression on it, once it found like an NAN value, it will break the function and you'll like receive an error. And so this is basically to help make sure you don't run into errors further down the line. There are other ways. Instead of dropping your null values, you can use something called imputation. So you can impute values, right? And so imputing is basically like if you have like a null value, for example, then if you have a null value, it will just basically insert the mean into that value, because so that's another way to get rid of null data in your data sets. So yeah. Okay, so what's the average random rainfall that usually falls? So you know how there's the mean, right? That's the average. Well, oh yeah, I just want to see if you guys can read the describe function here. But that's the average, and yeah, you passed your test. So yeah, here I'm just explaining how we asked ourselves the question, what's the average amount of rainfall, and we found it, right? So let's try practice selecting columns again. Rainfall column below. Alright, so, oh shoot. Right here we're just trying to practice or select the rainfall, and it will be apparent why we're doing this later on. But okay, yeah. So there, instead of like doing the scribe, you can actually use individual Python functions to get the mean or mode of datasets. So okay, I'm just gonna do this right here. But this will basically it'll basically calculate the mean for a specific column of your data set, and you don't have to use describe, so it's pretty useful. And this should, assertion is always true. Wait, what? That's not an average. Okay, I'll figure that out later. But anyway, let's try to sum the data from the rainfall column. So yeah. So there's sum. You can get the sum of all the values from a column. These functions only work for like numeric or numeric columns or numeric attributes, and so yeah, keep that in mind. Oh yeah, and these are all functions of the Python data frame class. So yeah, because this is actually a column is still considered a data frame, I think. Oh, it's a series. Huh. Whatever. But you get what I mean. You get what I mean, right? Series and the data frame have these kind of things, and you can look at that way. Cool. Yeah, notice the average rainfall has the same values we were told from the describe function. Yeah, max. Okay. Yeah, average rainfall, which was the mean. Anyway. Okay, so this function is pretty interesting. We want to sometimes, if we're working with variables that have that are categorical variables, let's say if we have like an attribute called animals, and then we have like cats and dogs and horses and elephants underneath or in the rows for that column, then we want to see what are all the possible combinations of the variables. So the categorical variable in our data set is, let me just copy this, is this one. This is the name of the station. And we want to see, hey, what are all the possible names of the stations that we have in our data set? So let's put in name dot unique. Alright, and so this will basically look at all the unique names. I've already put them into the assert statement, and I've passed. But yeah, unique names will basically show you the unique values of the data set. Yeah, oh, it comes into an array. I think it's a Numpy array. Yeah, so later on you're going to see me converting this into a Python list, because it's a nice Numpy array because it's quicker and easier to work with afterwards. But yeah, sometimes you just want to turn to a list for simplicity's sake. So yeah, there are other functions like some mean, unique, like mode, median, etc. These are good at glancing at your data set, which is the first step when you're looking at a data set. And yeah, so now that you guys have seen these functions, if you've gathered pretty useful information, or you have a pretty good skill set, just selecting columns alone and find unique, or like trying to find the sum and all that stuff, that's pretty good for a start, right? I'm gonna go over some more functions afterwards, and yeah, and I'll explain. Make sure you don't have any questions. Okay. But yeah. So right now, let's run the cell. Okay, I'm curious. I want to know what is the average rainfall for every hour of the day. So, it's interesting. Let's just run all these cells first to see how it looks like. Okay, yeah, whatever. But basically, to try to see how to try to see the average rainfall for every hour of the day, I'm basically going to, first I'm going to make a copy of the data set, of the data frame. And then this new syntax. This is an iteration syntax, so it'll loop through every single row of your data frame, and it'll perform the function, or it'll run this code underneath it. And why we're doing this, because we want to basically take a look at the date value, for example, and we want to get the actual date. Oh, we actually want to get the hour, so the hour of the date taken. So I'm splitting it on the t variable, and so yeah, this is the time of when the value was taken, or when the precipitation value was measured. And so yeah, that's basically what I'm doing here for every single row. I'm taking this time and I'm adding it into a new column of the data frame called time right here. And so I'm just taking this and I'm plopping it over here. So this in itself is feature engineering. Instead of this weird string that we can't really understand, we're taking this weird string and extracting the time out of it. And so this describes more information than a weird string. And computers or algorithms will look and they'll be able to understand this time because it's numerical once we turn it to a number. Okay, it's still a string, but you guys understand what I'm saying, right? We're trying to extract data and make it simpler for algorithms to look at it in the future, because a computer really can't find patterns out of this. It's a string, right? But yeah, so we're setting the value time. So for every single row, it's going to set the time index with the time gathered from here. Now let's try to run unique, see how many unique times. So yeah, it seems like they take measurements every 5 minutes. So here, 12 o'clock, 12:05, 12:10, all the way to 11:55 p.m. And so yeah, so that's pretty interesting to know. Every single insight you gather is one step closer to helping you reach your objectives when looking at data. And so right now, we're trying to find how much rainfall matches with every single hour of every single day, right? But first, let's try to see the sum of the average rainfall for the first hour. So I've ran the cell, and this entire data set only contains measurements that were taken from the first hour. So this is another useful skill that you guys should learn, because so you've learned iteration, you've learned selecting columns, but let's say you want to select columns based on a certain requirement, and our requirement here is that it has to be the first hour every single day. So as usual, we take our data frame, and then we, instead of like an attribute or a column name, we have the data frame again with the column name, and here is our condition, equals the first hour. And so if a row contains the first hour, then it's going to be added to this new data frame, which is first minute data frame, or should be more aptly named first. Actually, no, it is the first minute of the day. So yeah, I guess it's aptly named. But yeah. Now let's try to manipulate the data again and add a new hour column. So up here we've taken the time out of the date. Now we're going to take the hour. So again, we're iterating through the rows, looking at the time. This time, instead of splitting by the value t, we are splitting by the colon. And so taking the first one, so yeah, because this is the hour value. And so, and then afterwards we're setting the hour into a new hour column, into the data frame. And then we're gonna take a look at it. I'm gonna let it run. Yeah. You guys have any questions so far? Alright, no questions? Alright, oh, cool fact. If you can see this favicon, there's a processing icon when you're processing, I guess. A little tidbit for people. If you're like analyzing large data sets, this is actually a slow implementation to iterate through all the rows, there are faster functions. But if you find that the current method is a bit too slow, then talk to me about it, and I'll give you a faster function. Or you can just search up faster ways to iterate through data frames in Python. But yeah, a little tidbit: if you're ever processing something and it's taking a really long time, you might want to stop your process and implement like a percentage bar or a count, like it's really helpful because it'll tell you that you're making progress, and you'll be able to estimate how long it'll take for the entire operation to finish. Most people just run like functions like this overnight, or if you're training machine learning models, yeah, people run it overnight. But yeah, so now we have our new hour column, and it explains the hour of every single day, or this one rather. You get what I mean. Yeah, so you notice how I selected the first hour of every day, right? Let's go back to that, and I'm selecting this is the transform data frame, so it's oh wait, this is weird because it should already be selected. Whoops. Yeah, I know this should okay, whatever. But yeah, notice how we're selecting based on condition, and it's showing you the mean of all the rainfalls that have had an hour. This should also work if I gave in the first minute data frame. Oh no, never mind. That's the first minute data frame. Okay, never mind. Yeah. But yeah, we're selecting the first hour. Now let's try to do the same thing for all the hours in the day. Might take it didn't take a while. Oh yeah, because we've generated the hours, and now for every hour we're going to turn to a string. If the string is equals to 1, string hours equals to 0 plus. Oh yeah, so basically if it's the first hour, it's usually like a single number, and I'm basically trying to have 0 0, so all these columns match up. So it's just like string formatting. Oh yeah, I mentioned it here, formatting. So here I'm actually selecting the hour. Again, if the current hour is equals to the current hour in the data frame, I'm going to select that row, and that row is going to be stored into this variable. And I'm going to add, this is going to be that column of the data frame. Yeah, so yeah, this is going to represent the column of that hour in the data frame. I'm going to select it, calculate the mean for that, and then afterwards I'm going to put it into an array to just hold the data while I process. And it's going to do that for every single hour. It's going to increase hour by 1. It's going to try to see if it matches the hour, and then it's finally going to print it out. So yeah, here are all the averages for the hours. In the next tutorial, I'm actually going to plot this so you can actually see that there are differences, or in rainfall for every single hour of every single day. Maybe because it's like, I don't know, midday is the sun's here and it's hotter and there's less precipitation. And so yeah, you're going to see those trends. But that's next week. So looking at this data, we can see that precipitation happens most at 2 a.m., which is right here, 0.4. And that's crazy. Yeah, it's interesting. It'd be interesting to see how this data differs if we have more data. So I think I'm only selecting like the 2017 one right now, but there are several years left of data, and so yeah, these values will obviously change as we have more data, right? Right. One last selection method. Oh, right. Well, let's say you have a condition. You're trying to select a column, but you have two conditions, right? Let's say you're trying to select it belongs to the first hour, but it also came from a station with this station name. So the way you select stuff like that is to use, just look at the syntax here, name the data frame plus the first attribute, and all this is in a bracket, and you have an and. So this condition and this condition. It's sort of like an if statement, right? There's a Boolean logic in here. I'll get all the rows with this selection tool and put it into here, and then if we click on it, or if we run the cell, we'll actually see that we've selected 30 rows with these two features, and that's basically one last selection method. These selection methods, so selecting, looping, finding a mean, and all that stuff, all this knowledge is gonna basically come with you for like 80 or to 95% of your analysis, because so much of your time is spent gathering insights, doing feature engineering. It's crazy, because like you see, generating the models, the fun part, that's like the last 10 to 5% of your time. Most of your time is actual cleaning the data, gathering the insights, and yeah. So workshop number 1 is really important, and I'm glad you guys all came here today. So yeah, just use them. Okay, so now that we've talked about generating our data frame and actually creating the features, we have to save our data. So we want to save our features because, like, look, we took like a minute or two to generate these two columns, right? Well, let's like save it. So next time when we come back into our notebook, we don't have to rerun all those cells. We can save it and make progress. So in Python there's this variable, or this a file type called a Pickle File, and so it will basically save it into one of the folders on our data frame. So if I do this, it saved it into our data frame, or into right here. If you guys look at my data, rainfall data. Oh wait, sorry. Save data frames. I made a folder for you guys, so you can see right here. It saved it as workshop rainfall data frame, and it's right here. This is the actual data frame and the location of it, right? Yeah. So next time, all you just have to do is provide the same file path and load it up, which we'll be doing in workshop number 2. So yeah, that's it. That's basically the tutorial. I hope you guys enjoyed this stream. I'll be sticking around for the next several minutes, so if you guys have any questions, please ask. And yeah, if you have any problems or questions on data set, or if you want some tips, just throw it my way.
You guys can open your mic if you need to.
Yeah. How do you combine multiple data sets into one? Oh, okay. Okay, actually, it's in Workshop 2. It should have been placed in Workshop 1, but I figured Workshop 1 was kind of getting long, and I really wanted you guys to master the looping function. But basically, if we hop into Workshop 2, which I can't because I opened Jupyter in the wrong directory. Okay, yeah, so it's going to open our instance. Oh, whoa. Okay. But yeah, workshop 2. So there's a function called the join, an inner joined. This is the Python one. Oh, okay, yeah. It's right here. We're actually basically you want to have both data frames. You want both data frames to have the same column attribute. So the function knows which column to merge the two data frames on, and so join. Oh yeah, sorry, it's a merge. Merge is the function, and so yeah, merging this data frame, this name. It's on workshop number 2, so just open it and just scroll to where I am. It's going to be recorded on stream. You're going to know where it is, and left on name. So this is the name of the station. Outer join. There are different kinds of joining, and so this is the type. But yeah, that's usually how you join data frames. Any other questions? Alright, yeah, so make sure you guys work on workshop number 2 this week, because I'll be covering the answers next week. Workshop number 2 is like visualization. It's pretty important because your presentation depends on visuals and your abstract as well. So yeah, I'll be posting the answers notebook onto the GitHub. I'll just push, and then you guys can take a look at it. Yeah, again, if you guys have any issues or any problems, please like type it in or express your concerns on Slack. If you missed or if you want more explanation on a certain section of this tutorial, I'll be more than happy to help you guys. But yeah, I'll see you guys next week, and I hope to see you when we do workshop 2. Okay, bye guys.